benchmarking models with MLAgility. Like I mentioned before, MLAgility is our open source benchmarking tool. We make it open source because we want to be completely transparent with how we do our benchmarks. And we say we're an order of magnitude, 2 orders of magnitude better than the competition. We really want to back it up, make sure it's reproducible, and make sure people understand how we do benchmarks. So maybe before even going into how MLAgility works, I can show you this MLAgility Hugging Face page over here. I've already shown this before earlier. I'm just going to talk about this a bit more in this section. And we talk about how the models work and compile with Groq and how it compares to other vendors too. So over here, we can compare it to a baseline of NVIDIA and see how much we do. It's pretty good. And we can see kind of how the compilers improved over time. This is over the course of about a year, less than a year, and they've improved quite a lot. We test models from a wide range of sources, so Torch Vision, CNN, vision transformer type models, Hugging Face, these are more natural language processing type models. Torch Hub kind of has a mix of everything. And the question, a good question we could ask is, why do we have our own benchmarking methodology? Why do we have our own benchmarking framework in addition to transparency? So why do we have MLAgility in addition, or instead of just using MLPerf? And the reason we have that is because MLPerf, while being great, it's quite restrictive to a certain subset of models. The landscape changes all the time. And if you're not constantly updating these models, it may not be representative of how your hardware may do in whatever field. And on top of that, MLPerf allows vendors or allows people to really dial down into, let's say, the kernel level and really optimize for performance. However, that performance doesn't necessarily translate into other applications. You may have amazing performance in, let's say, ResNet 50, but once you go to like the VGG16, you may not have the same performance. And that's why we have MLAgility. We have a wide range of models, we benchmark across them, so you kind of see holistically how these workloads run on whatever hardware and with whatever runtime. All right. And if you go a bit further down, you can kind of see how we do with all the different kinds of models. We have our AlexNets, our BERTs, our BARTs, our ConvNext, and so on and so forth. So if you're interested in kind of using Groq for whatever reason, whatever application, if it were there already, great, you can kind of see how we do. If not, you can kind of probably gauge how you would do by comparing it to similar models. All right. Now, I'm going to talk about MLAgility, the devices and runtimes which we support, how you can interface it with the Benchit CLI, how you can generate reports and generate that Hugging Face page visualization with Streamlit and future work which we're currently doing. So, like I mentioned before, we support a wide range of architectures and also runtimes. We support the NVIDIA GPUs, this is, the H100s, the A100s, the V100, and so on. CPUs, AMD, and also Intel. And we support, of course, Groq via Groqflow. We have different runtimes supported. So for the GPU, we use TensorRT, which is NVIDIA's optimized inference runtime. And for the CPU, we have a number of like alternatives. We have Onyx runtime, we have vanilla PyTorch eager, also have PyTorch compiled. Yeah, so you could, compare different hardwares against each other, or for example, in the same hardware, you could compare different runtimes. So I could compare Onyx runtime to PyTorch, see how that goes. That's actually an analysis we're doing right now. So how would you work with MLAgility? So this is completely open source. You can find this over here on our GitHub page. We have installation instructions. You can go through them. I actually go through this in the previous seminar, so please feel free to look through it. If not, just look through this README page. And over here, I'm just going to go through how you interface with the Benchit CLI. So you specify the model which you want to benchmark, pass it into the Benchit command, and then specify your device, whether you want to use Groq to benchmark, NVIDIA to benchmark, or maybe a CPU to benchmark. So over here, we're specifying the device to be a CPU, and you can see the benchmarking output is very similar to the Groq flow output, and also the NVIDIA example where we're benchmarking an NVIDIA with the TensorRT runtime. So over here, it specifies we're benchmarking on the A100 with 40 gigabytes. And similar to the Groqflow example, all of the artifacts are saved in your cache directory, but instead of it being Groqflow, it's in your .cache/MLAgility directory. So I mentioned before, you pass in a file into the benchit command, and this is kind of how you want to specify your file. It's very similar to how you specify Groqflow. You instantiate your model, you specify the inputs, and then you call your model. You put this into a file. You ideally would want to have labels. So for example, your author, kind of where it's from, if it's computer vision, if it's NLP, it's just because it's easier to track. And then once you have this visualization, you can kind of do some fancy tricks with it and maybe see how well you perform depending on whether it's computer vision, whether it's natural language processing. But that's completely up to you too. And once you specify these files, you can do a lot of them. You can even use, for example, large language models with function calling. I've used Groq Chat to generate those files for me. And then once you have a lot of these files which you want to benchmark, you can just use this benchit command on all the Python files, and you can just generate a report from that. And you can use that with the benchit report command. I must say that we're currently working on this command. So if you try it this week, maybe later on in the week we'll get it working. But right now it's still a work in progress. All right. So right now I just want to talk about the limitations and future work of MLAgility. So right now MLAgility is only taking into account on-chip latency. So we're not including PCIe or any kind of runtime overheads. On the Groq chip, we're taking into account cycle counts. And for the GPU, for example, we're taking into account on-chip performance. For the Groq system, it's something you can do where you just take the cycle count, divide it by the clock speed, and you get the on-chip performance. For the GPU, because things aren't deterministic, or even the CPU, you actually have to measure what's going on chip. It's apples to apples in terms of on chip. But if you wanted, let's say, an end-to-end example, that's something we're currently working on. Another limitation is we're only working with batch 1. This is something you can easily change just by kind of changing the inputs into your models. And Chris is going to talk about how you can kind of vary batches and get performance from that and kind of determine which batch is best for you if you, let's say, wanted to maximize throughput. But yeah, these are the limitations of MLAgility right now that are currently being worked on. And a lot of these will actually drop by the end of the week. So for future work, we're going to include additional classes and models. So for example, diffusion models, GNNs. We're going to do experiments that sweep over batch size and input size, include micro benchmarks. So for example, seeing how a matmul scales going from 1 chip to 2 chip. So this includes runtime and also C2C connections. And we're going to increase the number of devices from other vendors, maybe include AMD GPUs, so on and so forth, and include more runtimes too. Yeah, so just to recap, MLAgility is a completely open source benchmarking tool, and we use it to benchmark acceleration hardware, for example, Groq, and runtimes too. And if you wanted to see benchmarks, we have our Hugging Face page. If you wanted to add your own benchmarks, just submit a pull request, and if you have access to the ALCF system, you can actually run those benchmarks. Thank you. That's all. That's all from my session, and I think that concludes today's session too.